When you want to travel a long distance, say from one continent to another, you book an airplane flight, expecting to spend some hours in the air. However, when it comes to space travel, you need to travel faster because all the points of interest are so far away. Hi, technology and science lovers. Welcome to Spaceability. Let's get started. Space explorers have always been searching for a way to travel faster than light, which will allow them to get to deep space more quickly. All the methods discovered have significant drawbacks, but scientists have found a new way. How does it work? What are the requirements? How soon will you be able to travel with it? Scientists have tried to find a way to travel at the speed of light. This is interesting as humans will finally become an interplanetary species. For instance, SpaceX billionaire CEO Elon Musk wants to form a settlement on Mars, but his explorers have to bear, at the minimum, 5 months of travel through space before touching down on the red planet. This can even reach almost a year, depending on how close the two planets are. And that is with all the hazards it brings before touching down on the red planet. However, with the speed of light travel, they can make the long trip in less than 4 minutes. Researchers have tried many different methods to achieve traveling at a very high speed. To go faster, you need to increase kinetic energy. The problem is that it takes a lot of kinetic energy to increase speed. For example, the M drive, which was touted as the technology that would take us to the most distant parts of the universe very fast. This invention, which has even been patented, theoretically works by trapping microwaves in a shaped chamber where their bouncing produces thrust. The chamber is closed, meaning from the outside, it will appear to simply move without any fuel input or any thrust output. The M drive relies on Newton's second law, where force is defined as the rate of change of momentum. Thus, an electromagnetic, or M, wave traveling at the speed of light has a certain momentum that will transfer to a reflector, resulting in a tiny force. However, the warp drive shows great promises, as shown by Dr. Eric Lentz, a physicist with over 10 years of experience in practical applications. Lentz wasn't even the first to work on making the warp drive a reality, and not just sci-fi. The first person to attempt it was the Mexican mathematician, Miguel Alcubierre. In 1994, his proposal became the beginning of the official literature on warp drives. Unfortunately, the Alcubierre warp drive, as it has come to be known, requires a staggering amount of energy, along with the dreaded exotic matter as a co-ingredient. This highly radioactive stuff is only theoretical and is not something researchers have actually observed in nature, much less created. A handful of variations have been suggested since, including a 2010 update to the Alcubierre drive's physical design made by former NASA engineer Dr. Harold G. Sonny White. His update reduced the amount of energy needed to a less daunting number, even though it was still not practical because the solution also still required exotic matter, albeit significantly less than the Alcubierre solution. Another group of researchers from Switzerland known as Applied Physics, APL, put forth their own concept. Interestingly, their drive did not need any exotic material to create its warp bubble. However, their model could not go beyond the speed of light, which is the holy grail of space travel. To explain how his concept is different from those already proposed, Lentz first points to the physical structure of the classical Alcubierre drive, on which nearly all other solutions are more or less based. He said the Alcubierre solution provided an intuitive picture of what a warp drive would do, that is, contract the space immediately in front of the central region containing the ship or transport, and expand the space immediately behind. This shows the warp drive as a wave of curvature on which a ship will ride to its destination. Even though it is the cornerstone of warp travel, Lentz argues it is not even the essential feature. Instead, he says, a solution proposed by physicist José Notario back in 2002 showed that the expansion and contraction weren't necessary to transport the ship forward. That work prompted him to rethink how a warp could be created using only traditional matter and not exotic matter. Notario was able to prove that the expansion could be trivial or zero everywhere and still perform the same task of transporting a ship. This is a significant breakthrough because it means that exotic matter that warps the space in front of the theoretical passenger and behind them in nearly all theoretical warp drive solutions is no longer needed. And by building on Notario's theory, Lentz created his own variation that he believes is even more viable because it is rooted in conventional physics. Where does Lentz want to take his warp drive from here? He said the next target is to make a warp bubble capable of moving at 1% of the speed of light using a modern-day fission reactor. The physicist said he would consider patenting his warp drive, but he made it clear his work is just a part of a larger, rapidly growing body of work in this area and that the recent increase in new warp drive concepts since Alcubierre's 1994 proposal gives those in his field hope that a real, testable version may be closer than we think. That's all for today, folks. See you in the next video. Till then, be safe and take care.